Hello everyone. This week we are continuing our computer and network security class with a very new chapter. We just finished network security and network vulnerabilities. We spent a good chunk of time discussing the details of protocols and how we can break those. And now we're getting into a very important topic for any software developer, vulnerabilities that their software may have. We will be discussing these for 1.5 weeks roughly, and we will be learning about software weaknesses and how to defend against those. And as I always do, the t-shirt of the day is Seeds of Hope by Action Aid. So hoping that you're all doing very well and enjoying those videos and learning a lot of things. The outline for this week's and next week's lectures. We will talk a lot about buffer overflows that are a quite complex and low-level type of attack to your software. So we'll split these in a couple of parts. And you have a homework assignment where you apply very simple principles of a buffer overflow. You're not completing a buffer overflow. I usually give this assignment to graduate classes to find completely blindly a buffer overflow in a program as a hacker would do. But like I said, again, pretty complex attacks. So we're doing a little bit more doable type of homework assignment. And then we will talk, of course, about defenses, because it's fine to learn the weaknesses of your software and how things can be taken advantage of, but it's important to discuss solutions to these problems. And then we will discuss other software vulnerabilities. There's a number of those in your book. So these first 3 bullets cover chapter 3.1 in your book. And then we will discuss malware, chapter 3.2, and then how we can defend from all those issues with all of these software issues with secure coding principles, but also software that can protect us from other bad software. So we're getting into buffer overflow, and as you can see, I have a slide with C code because this is the most common language that we encounter these type of attacks, and a little bit of a motivation. Again, this is a low-level attack, somebody needs to understand very well how the machine works, CPU, assembly, and things along those lines. The problem with C is that it has these functions such as string copy, where you can copy an input to a buffer, and string copy does not check if that input, that parameter S, can fit in the buffer of 10 characters in this example. And therefore, because of this, programs may crash because parts of the memory get overwritten, because the language doesn't offer protections. The function string copy doesn't check if there's sufficient space to copy S to buffer. So this is something that the developer has to do, and of course, as you can understand, because the developer may be negligent due to deadlines and things along those lines, they may fail to make these checks, and crashing a program is not a big deal, but being able to inject malicious code into a program, which can happen with this buffer overflow attack, that is a big deal. That can that can elevate privileges, cause attacks that we call elevation of privileges to happen. As we will see, this is very doable with a buffer overflow, from starting as a regular user and becoming root, becoming the ever-controlling root that can do anything, see passwords, install things, and all that. And all of this can happen because there's a function that doesn't check limits, and there's a negligent developer that doesn't make sure that the code abides by principles of secure coding. So we will see more details of how we can execute this quite complex attack and inject code that elevates the privileges of an adversary. So with all of this motivation and showing you how interesting this attack may be, I also want to get into the part of the background that you need to understand this buffer overflow attack a little more. So you do need to understand some C functions, which I will be explaining to you. This class does not have prerequisite operating systems, which is where you will learn C. However, C is a high-level language, very similar to Java, so you will not have an issue understanding the C code, and of course, I will be explaining it thoroughly. Then you also need to understand a little bit of assembly and machine language if you're going to do a buffer overflow blindly. Over here, like I said, in your homework assignment, you're doing just some steps that leads to buffer overflow. You're not doing what I assign to graduate students, find buffer overflow from an unknown program. And then the other thing that you need to understand is how memory works and how system calls are made. And I'm going to explain these in a lot of detail. First things first, you also need to understand what a buffer is, which I think most of you understand. It's a contiguous block of computer memory that holds multiple data that could be of the same type. And C is a quite low-level language that kind of accesses these buffers directly through pointers and that access memory addresses, and you need to understand that such as in Java and Python, arrays in C can be static or dynamic, and dynamic arrays could be allocated in a runtime stack or a growing heap, like you may have heard in your Java programs, whereas a stack is more for the static data, and this is what we're going to be focusing. We're going to be focusing on the stack. It's looking at static data structures that have a specific size, that don't grow dynamically with the amount of data that we're entering. We're focusing on this because it's easier. It's a very common attack. It's still happening, especially with old legacy code. And we're focusing on this because it's also more simple to explain. Of course, there are attacks in the dynamic heap allocating memory. However, they're much more difficult to explain. Again, more a graduate topic than an undergraduate topic, or if you want to get really, really deep into malware analysis. So what is a buffer overflow? A buffer overflow, as I mentioned in the motivation slide, is a way of executing code arbitrarily. And this code can do different things. One is, as I mentioned, an elevation of privilege. You start executing this program that may be a trusted program in the computer as a regular user, and then you can elevate your privileges and become root. A second thing that this arbitrary code would be malicious virus or a self-propagating virus, which we call a worm. That worm could infect other computers in the network, in the enterprise, and then create a botnet for a nice denial of service. not nice, of course, ironically nice. So a buffer overflow is a very versatile type of attack that can lead to other attacks. It can lead to breach of confidentiality, stealing of data and all that, with that arbitrary code execution becoming root, leak of passwords and things along those lines. It can lead to lack of availability and, of course, even lack of integrity, because if somebody has root privileges or infects computers with malware, they can affect the integrity of the messages and communications that come out of these computers. So the buffer overflow is a really systematic type of attack, and the steps are very, very specific. First, you need to inject this malicious code into a buffer, and then you need to overflow a return address that is a key to lead your code execution to this specific part of the buffer that will execute the malicious code. So that's the third step, to redirect control flow to the attack code. So that's the very craftsy part of buffer overflow, manipulating code execution to go exactly at the point that you want in memory. And that's the point that you want where you have injected the malicious code. And finally, the last step, the easy step actually, is executing the attack code. Once you find a way to manipulate the software, the program execution, to go exactly to that point of the memory that you have injected your malicious code, then executing the code is the malicious code is a matter of time. So we will discuss in a lot of detail all of these steps and explain very well how they work, so that this can also help you in your homework, that you're executing some of these steps for a buffer overflow. So as I mentioned before, this attack targets specifically the stack, because it's a static area of the memory that is used in our code execution. But also this attack can target the heap. So do not feel too safe because you're not using C, that is mostly using the static stack for code execution, and Java uses a heap, which is dynamic, and you have this dynamic garbage collection and all that. Do not feel too safe about that, because there are heap overflows that can be very detrimental as well. So whatever you do when you're coding, you got to be diligent and make sure that you're coding securely. So there are related attacks to the buffer overflow. These are called integer overflows. So, for example, Java does not have as large integers as Python. So you can overflow, you can give some really huge integer values as input, and if there's no check, then that could overflow the heap. And if you have the craftsy type of attack, you could even execute malicious code, because like we've said, crashing software is not a huge deal. Actually, getting malicious code to execute, that's the big deal with the buffer overflow. We can crash our software all the time testing it, right? Other related attacks are format string attacks. And as I have said before, what these attacks are doing are changing privileges and controls, and these attacks rely very much on addressing in an operating system, memory addressing, and of course, absolute versus relative addresses really affect how well you can execute and replicate this kind of attacks. Let's now do a deep dive into the address space. As you can see here, I have drawn in this slide a square that emulates the address space in your computer. The lowest memory is this 0 memory in hexadecimal that is at the bottom. The highest is this FFF, all ones, that is at the top. There are some specific parts in the memory that you're not allowed to mess with. Like, for example, look at the bottom part where the code of your program resides. This is read-only memory. Nobody can write to this and inject malicious code. This is where your software is loaded. Then the top part that is called kernel space, this is operating system environment variables, and this is another place that one cannot tamper with. It's read-only. And then we have some static data where there may be static variables and all that. But what I want to point your attention is the heap and the stack. The heap is where we put our dynamic data structures. As you've learned, let's say a dynamic array list could be placed over there and grow going upwards, as you can see as the arrow shows. And then the stack, where we put our static variables, and that grows that grows from top to bottom. So the stack is where we're going to be focusing on in this class for our buffer overflows. But as I've mentioned before, there are heap overflows. They're even more difficult. However, they are very much true attacks that are happening. So with that, you now have a very good view of how the memory works when the hardware memory works when your software is being executed.